we want to introduce, let me get this right, the Douglas MacArthur Girls Leadership Academy students. Can you raise your hands? There they are. Thanks for coming. They were here a few weeks ago for an Ohio Space Grant biomimicry activity, and we're so pleased that their teacher could bring them back here again. We want you guys to be the future of rabbit holes. Did you hear that story? Of penguin feathers. We'd love to have you guys along for the ride with us.
Okay, good morning, everyone. My name is Ochaya. I am a professor of business strategy and innovation at Baldwin Wallace University, where I have been now for 15 years. I will teach just about anything they'll let me teach, except accounting and finance. That I will stay away from. But I spent 17 years in the corporate space, 5 years as an executive vice president for R&D, product development, business development, 2 years in China, 2 years in Brazil, some time in Amsterdam. So the panel that's going to be speaking today is going to remind me a lot of what I left behind to come teach. So you guys are in for a treat. It is always hard to follow Peter. I saw that I'm going to be following him on the agenda, and it's like, okay, not again. So I've known Peter for 15 years. I could listen to Peter all day. He has a lot of insights, which I think we saw at the beginning, and he did a great job setting the stage for this particular group here. At the same time, I recognize that we are the last group standing between you and lunch, and you and your wherever you're going to go next. So we hope that you can still pay attention to what we have to speak to today, because the last couple of days have reinforced exactly some of the challenges that I have dealt with, that I know a lot of you are dealing with. There are so many nuances to it. I think one of the things I'd love for us to hear from this panel today is how to bridge this idea of starting as a new venture. A lot of you are in small organizations trying to do this thing biomimicry. I grew up in large organizations, Fortune 500. I had a lot of money to spend on problems that we agreed were important, but that's not the case, as we heard yesterday, with a lot of the ideas that we have going on here. So one of the things I'm going to ask the panelists to start thinking about is how to speak to the challenges and opportunities that's in front of them, and also, more importantly, how to draw not just government and our partners in education, but also in industry, because I think we need both. We need all three on the table. So with that, I'm not going to take up any more time. I would like to introduce, first speaker is Dennis. Dennis Tuckowski is from the International Council of Systems Engineering, which is INCOSE. Actually, we had a conference that he introduced us to that. Dennis also has 18 years of experience in product development, which you're going to tell us about, but obviously is here to talk to us about the challenges of bringing biology to commercialization. So Dennis.
Thank you, Van, and thank you, OAI, for inviting me to come here to speak today. On behalf of INCOSE and the Natural Systems Working Group, which I'm chair of. My presentation today is really about leveraging the systems engineering product development processes to better foster the adoption of the great materials that you are all helping develop. Just, I guess, a little bit more about my background. And there's a QR code to my LinkedIn page if you want to connect with me. I have over 18 years experience in product development. I currently work for SAIC, but my background, really, I've worked for an automotive, GE, Whirlpool, and currently in defense. I've worked on many different materials, a lot of materials that have been brought up here, steels, plastics, glass, adhesives, all of that. And the products that you use every day, we use those materials and have those similar challenges. In addition, I've worked on way too many projects, as well as I'm chair of the INCOSE Natural Systems Working Group. And just a little bit about myself and why I'm interested in this is that I enjoy being in nature. I'm actually headed out from here to go down to Tennessee to go backpacking. And I have two small kids that I want to embed, a sense of exploration and interest in nature over their electronic devices and Roblox and Minecraft. So with that, keep going here. So I just want to, what I'm going to cover today is what is the objective of the presentation, what is INCOSE and the Natural Systems Working Group, because I think that could be a great resource for many of you. How do we see the challenges of implementing the great materials that you're working on, and kind of going into what is the systems engineering and product development processes that we have to use to put those products into production, and opportunities and potential collaborations for implementing those materials and growing those capabilities. So really the objective here is, again, provide a systems engineering or product development perspective on the challenges to implementing these materials. I realize that it's not immediately obvious why we don't always put stuff in production. And ultimately, we want to help the teams here developing those materials increase their odds of getting them up into mass production so that everybody can benefit. A little bit more about INCOSE, and then again, the QR code can take you to the page. As Ven kind of mentioned, it is the International Council on Systems Engineering. We are a global organization. It is multifaceted. It is not just systems engineers, because it takes more than just systems engineers to create products and create systems. But really, the motto is a better world through a systems approach. And as I go through this, I hope you see that I think that this is a great way for connecting the materials that you're working and helping put those into production. And again, a QR code to our Natural Systems Working Group site. So our particular focus is on systems engineering processes and connecting those with nature-based solutions like bio-inspiration, and trying to enable them so that systems engineers can take full advantage of those benefits. We recently, INCOSE has a systems engineering handbook. In the latest edition, we actually did get natural systems added to the systems engineering handbook, as well as we have released a primer that I'll share a QR code to as well. It's focused for systems engineers, but it's a great read for everybody. Within our working group, we do have work streams for bio-inspired design, system dynamics, and model-based natural systems modeling. We have monthly presentations, networking, and collaborations. You're more than welcome to join us. It's not just systems engineers. As a matter of fact, we have artists, architects, electrical engineers, a whole gambit. And that's really kind of like the secret sauce of our group, is that we need those all those different skill sets. So how we see them, what are the challenges that I have as a product development engineer for putting bio-inspired materials into production? First is that we have a very limited time for the selection of materials. And we have to address some of the challenges that with each project, which is we have product requirements. So whatever we're designing, we have to still meet the product functional requirements. Obviously, cost is a big thing, as Lorenzo had noticed, as cost is king usually. We have to meet or consider existing production applications. So if your material requires a whole new manufacturing process, that is very disruptive. We have testing and certification of materials. Just as you would probably not enjoy somebody using an untested material in a toothbrush, we have to have certification of materials. They have to be acknowledged. And then the overall development and timing. So we have to test and approve that material application for that product usage and for the constraints on that system. It is also requires multiple, a functional team buy-in. So it's not just systems engineers or engineers making the decision. You have quality, procurement, safety, regulatory, manufacturing. We have to have the whole organization. So what exactly, what does a systems engineer do? If hopefully this helps clear it up for you, because my parents still don't understand what I really do. Here are some, just some pictures of items that I know that systems engineers work on. I worked on the washing machine on the left there. But really, we're at the heart of the system design, and we're responsible for identifying the system concept, the architecture, and selecting the design. And we do that by identifying stakeholders of that system that we're designing, and we have to generate requirements for that system. And we're usually almost always given the triple constraint: cost, resources, and schedule. That is the triple constraint. And we have to manage complexity and risk to those three constraints. But we do this using established processes for product development. We have like the ISO 15288. When we typically put something into production, there are processes that we must follow to actually get it into production. So just a quick kind of, I guess, funny application here. And if you go back to 2022 Biocene, there was talk about like the Wi-Fi Bluetooth toaster. So I wanted to use this as an example. But on the left, you have the classic, well, that didn't really format well, but classic toaster where you might have just had electrical and mechanical engineering working on it. And now with your Bluetooth-enabled toaster, you're going to have mechanical, electrical, software controls, DevSecOps, because we don't want your information getting stolen, human-machine interface, and obviously systems engineering. And then there might be another one or two in there. So to make you delicious toast. And probably AI will be added in there very shortly as well. So the use of systems engineering is only growing as our products and our needs grow, continuing to get more complex. So you're going to see more of us behind the products. And so that does bring challenges for materials, but I would argue also a lot of opportunities because we're going into more and more high performance applications. So just where do we focus? Really on the development process of the product. And we have to plan ahead for what we call risks and opportunities. And that's where materials can help us identify or help us achieve and overcome some of those risks that we have. Because usually might have a design, but we can't achieve the design because we don't have materials that are currently capable of achieving that performance that is required. And we do all of this through our product development process. And so try to go over this not too in depth. And this is trying to like summarize an entire book in one slide here. But for the time scale, it can be, depending upon your system of interest, it could be, from a toaster to a space station, 9 months to 5 years. But we really start at the top, which is what is our business or mission need? And then from that, we have stakeholders that we identify and create requirements. And we choose the architectural solution for that and actually implement and design it, begin to implement it, and do what we call verification and validation. So did we build the right thing, and did we build it correctly? And those are some of the common stakeholders that we have to create requirements for. And that's not completely comprehensive. That's just a common list. And typically material selection happens down near the bottom of the V. So as we've selected our architecture and we need to create a design that will satisfy it. Focusing out a little bit here, you can see the product overall life cycle. So you might design a toaster, but then it actually has to be produced, it has to be used, and then when they're done with the toaster, what happens to it? So you can see the product development is just a small aspect of the actual overall life cycle. And here, so as I was pointing out, that's where typically the material selection is. But if we want to introduce a new material that is higher performance, that typically has to happen in an advanced development space because the timing, more often than not, never fits within our project timing and resources and scope. So that presents a different challenge. And as I was mentioning, we're held to the triple constraints, and we're unlikely to introduce new materials inside of the project. So we have to really focus on the advanced development stage of our process, and most companies have an advanced development. And even within advanced development, I think as Lorenzo had pointed out, we still have to prioritize because we have limited funding. So we focus on usually it's cost savings, quality improvements, current unmet needs, future unmet needs. So if to stay competitive in the future, what material performance properties are required. Upper management pet projects, that is a real thing. At one of the companies I work for, we had a advanced development project to make clear spherical ice, only because VP enjoyed clear spherical ice in their whiskey. And then more sustainable designs and materials, I put that as an asterisk because I would say that's probably an outlier, but it is growing. But ultimately, if it doesn't fit in this list here, it will not be prioritized. Just as a quick example, in 2015, Ford introduced the aluminum body over the traditional steel. It did reduce the vehicle weight by 15%, but it took over 6 years of development, and as best I can tell, it took hundreds of millions of dollars to actually implement. And downstream impact was all the body shops that worked on the vehicles had to buy hundreds of thousands of dollars of new tooling to support the aluminum bodywork. And plenty of critics, if you recall, Chevy actually made an ad making fun of the aluminum body when they dropped a load of bricks in it and showed how it would puncture the body. But there are benefits because you can save 15% of your body weight. So I guess my point here is that this is not necessarily a complex thing, right? Aluminum is not a new material, but it's complicated because it's a very mature product and a very mature industry. And if you're trying to enter a new material into a very mature industry, it is going to take a long time to get approval because everything is streamlined for efficiency. But that doesn't mean we shouldn't do it. We have plenty of benefits that we recognize because the extraordinary amount of diversity, highly optimized solutions as people have presented here, size, weight, power, sustainable growth, 4 billion years of evolution to really have optimized solutions, and ways to look for more sustainable material supply chains, what happens with that product after we're done using it. So what I would say, one of the first opportunities is work with, try to reach out to systems engineering. I'm trying to paint the picture here, is we have a very high level view of the product and the processes and the challenges that we have, and usually like an unmet need or a future unmet need where we need support and where you could focus your new material on. Just going very quickly, we have surface level properties as like the ice sticking, so like protection, friction, interfaces, and boundaries, up to the structural level, so foams or like the robotics, all the way up to like actual
Filtering.
Yeah, I guess I didn't fully format correctly, but process level even, how we filter or flow products. So again, I would encourage you to reach out to INCOSE. How can you increase the odds? Again, I would say reach out to advanced or sustainability teams. Define your materials advantages to key business attributes. I believe, again, the helicoid example, he did a great job of putting that in terms of what are key business attributes. And then relate your new material to current used materials. How is it better and what factors or values? And then demonstrate how it can achieve an unmet need that is current, or if you can show industry trends and how your material will help them achieve a future unmet need. And if possible, address frequent roadblocks. So material certification is a huge one. So if you can get it UL recognized, ISO, go through ISO testing, ROHS certified, because if you can hand an engineer a material data sheet on its performance characteristics, they can then model it and they can actually include it in their analysis for their material trade-offs. Giving us a chunk of material, we have to go and characterize it. That takes time, and it's usually won't fit inside of the project. And I would also argue leverage the trickle-down effect. So if you have a very high performance material, look at a niche market. Like I would say, professional road bikes that cost $20,000. That technology over about 5 years trickles down to now like an entry-level road bike. And with that, you start scaling up the production capabilities. An impressive EP. I mean, if you can get it to be a pet project, by all means. I'm going to have to go a little bit quicker here. Whoops. Baby. Probably.
You did, all right.
Yeah. It was there we go. I'm going to go very quickly here. So this is in part of our primer, and that's the QR code. We, with the help of Dr. Nagel, we have actually, for systems engineers, showed how through that V process, you can leverage bio-inspired and natural systems in that process, really fitting, breaking it down from form into function, and then translating that to biological or natural systems. So just collaboration opportunities, first thing is consider all levels of the supply chain. So not just, like the vehicle manufacturer, but you have assemblers, sub-assemblies, processed materials and raw material producers, and you can leverage them against each other, like create a demand for the need of your product. sustainability teams. Many companies have sustainability teams, but usually the people on those teams don't have a clue what they're doing, have a very undefined scope, so you can actually influence them and show them how your material is more sustainable. Understanding future industry trends, and again, mapping your material to that performance. Oops. And I turned it off.
We're almost there.
I was. Sorry about that.
Craig, oh, sorry.
There I go.
Night.
I'm on the speaker notes there, but. And again, you could work with material regulatory bodies for material certification, but also mapping it to areas of applications. So we all benefit from utilization of more sustainable materials. We totally acknowledge that. And with increasing complexity of our products and needs, we have a need for better materials, but we have to acknowledge the complexity with putting those into production. And I would argue understanding the product development process and how you can fit into that, I think you can increase your odds of getting it into production. I'm going to run over the wrap up here. So we have examples. I think people get copies of the presentation. I don't know. But there's also QR codes for our natural system working group primer and Zygote quarterly issue. Thank you.